Okay? The way we handle big numbers like the distance to the sun or the distance of the weight of a big shipping container or the numbers that we need to describe the weight of a big shipping container are all going to be using scientific notation. Now, scientific and exponential notation are the same exact kind of number. There's still something times 10 to the some power, like 3.67 times 10 to the minus 3, except that scientific numbers always put the decimal behind the first number. So it's 3 point something, 5 point something. Whereas exponential, they'll have the same properties, they add the same way, divide the same way as scientific, but they can put the decimal anywhere. You might have a number like 302.564 times 10 to the 5th. So the only reason I would even use scientific is so that when you want to compare my answers, you'll see that it's exactly the same because we all agreed to put the decimal in the same place. Now, when we deal with such huge ranges of numbers like the galaxy size or down to the atomic size, we need to have some way to show them instead of writing out all these zeros. A cup of just any atoms, any element like graphite, if you put a cup of graphite together, it would have 602 hextillion. Not billion, trillion, quadrillion, or pentillion. That's 602 hextillion. That's a huge number. So we got to get used to those. And what I want to say is that you're going to write them out as numbers times 10 to the. Okay? Now, when you're starting from a number this is called the positional notation, or it's the longhand form. The book calls it, I think, longhand form, or writing your answer out. Expanding numbers or writing them in scientific notation. Just look at the exponent. If the exponent here is larger than 1, when you expand it, the number has to be larger than 1. So I would move this decimal in a way to take this one, it says 3.2 times 10 to the 4th. I would move this decimal to a way because the exponent here is larger than 1. I would move it so that this expanded number is larger than 1. That means move that decimal to the right. So whatever the exponent is what the number expanded should be. Positive numbers get expanded to be bigger, 324,000. Okay? If a number has an exponent in the times 10 to the in a minus, that's less than 1. So when you write that number out, you have to expand the decimal in a way that makes it a smaller than 1 number, or put the decimal into the left and making the number 0.00156. So look at the exponent, this number that comes right here at the top. If it's positive, then when you expand it, it should be a bigger than 1 number. If that exponent is negative, then your number should be smaller than 1. The exponent is negative, smaller than 1, your number expanded should be smaller than 1. Okay? Now there are 2 segments in the book. We'll talk both in the end of the book. There's an appendix, and there's also the chapter part that deals with that is going to show you how to expand those. So what I want you to do is go into the worksheet below and make sure you're working your problems there to practice.